how to go from a sequence to an equation or a function. Consider a sequence whose first 5 terms, so this is the number 1, the first one, 8, 11, 14, 17, and 20. So first 5 terms. So that's kind of key. They're not just 5 terms, but they're the first 5. Write the function with the main of all integers n greater than or equal to 1 that can be used to define and continue the sequence. Well, if I were to write an equation, it would be f of x equals so it's going up by 3. 11 minus 8 is 3. 14 minus 11 is 3. So it's increasing by 3 each time. So I could say 3x plus I need to know where it started at when x was 0. When x was 1, we had an 8, so I'm going to go 1 below that, so 5. Does that work if I put in a 1? F of 1 equals 3 times 1 plus 5. Yeah, that's 8. So that's the first term. If I put in a 2, that'd be 3 times 2 plus 5. That's 6 plus 5. That's 11. Yeah, that's the second term. Good. Okay, but now we want to do a recursive function also. So we know that f of 1 is 8 and f of n is equal to f of n minus 1 plus 3. So if I wanted to get f of 2, the second one, I just go to f of 1 and add 3. F of 1 is 8. 8 plus 3 is 11, so that works. Well, let's consider a sequence where the first term is negative 8 and the next term is negative 4. Well, that's increasing by 4 each time. So an equation would say that f of x is equal to 4x, because it's increasing by 4 each time, and then minus 12. So I'm going to go 4 below. This would be number 1, so I need to find the 0 point within that intercept. Or I could say as a recursive function, f of 1 equals negative 8, and f of n equals f of n minus 1 plus 4. A sequence whose first five terms are 2, 7, 12. So f of x would be going up by 5 each time. 12 minus 7 is 5. 7 minus 2 is 5, so it's 5x. But this is the first one, so if x is 0, then I'd go 5 less than that, so that'd be negative 3. A cleaner way to write that would be just subtract 3. Adding a negative is the same as subtracting. Or I could write, well, f of 1 equals 2, and f of n equals f of n minus 1 plus 5. Or I could write, if I write f of 0 equals negative 3, then I could write, this one stays the same. Oops, better give myself a little more room there. F of n minus 1 is still plus 5. But if I tell it the 0 term, but if I say, actually, n is greater than or equal to 1, then we would just start at n equals 1. This equation works if you say that, well, if I change that to an n, if anything greater than or equal to 1, if I start with 1, that'd be 5 times 1 minus 3 is 2, so that gives us our first term, so that's good. Okay, the first term is negative 3, the next one is 1. That's an increase of 4. Is that the same increase there? Yes. So increasing by 4 each time, so we know that a function would be 4 larger each time. Starting at 4 down from that one, which would be negative 7. Or I could say f of 1 equals negative 3, and f of n equals f of n minus 1, the one before it, plus 4. I add 4 to the one before it to get the next one. Okay, if I had a term 8 to 4, that's going down by 6. That's going down by 6. So f of n equals negative 6x, or negative 6n but I have to go 6 higher than that one to start with, so plus 14. Well, I could say f of 1 is equal to 8, and f of n equals f of n minus 1 minus 6. So I could subtract 6 each time, or I could do negative 6 times the number,